LR-FS500 crack depth detector is an ultrasonic product. Its principle is to calculate the depth of concrete cracks by using the time for ultrasonic waves to bypass cracks in concrete. Its main features and functions are as follows. High magnification acquisition enables accurate response waveform in the face of complex working conditions and large distance testing. It can automatically search for the first wave and adjust the magnification during the ultrasound acquisition process. It is equipped with dual operation modes of touchscreen and buttons with more friendly human-machine interaction. With a positioning stamp, the position of the measurement point can be quickly located at the operation site without manual marking, which improves work efficiency. With the dedicated supporting online system software, batch test results are clear at a glance. The instrument consists of the host, transducer and positioning stamp. Among them, the host mainly comprises an LCD screen, a keypad, a sleep-breathing light, a receiving port, a launch port, a Type-C interface, a support frame, and a removable battery compartment. The ultrasonic transducer uses piezoelectric ceramic thickness vibration to emit and receive pulse waves. The positioning stamps can quickly locate the position of the transducer on the concrete surface. The stamps are divided into cross-seam positioning stamps and non-cross-seam positioning stamps, which need to be used together. Before performing the formal test, it is necessary to set up the crack test parameters. First, connect the two transducers to the host through the signal wire, and then press the power button to turn on the detector. The host automatically enters the main interface. The main interface contains three functions, namely test depth, manage data and set system. Click test depth to enter the crack test parameter interface. After entering the parameter interface, it will automatically enter the continuous measurement mode of the previous component, and some parameters of this interface are not available at this time. Click Create Compu on the upper right corner of the screen to create a new component for ultrasonic measurement. At this point, all parameters can be edited. Parameters that can be modified include component name. The component name can consist of letters, numbers, and symbols. Initial distance measurement. Input. The initial distance of measurement, the distance from the inner edge of the transducer, within the range of 10-500 mm, distance measurement increment. The increase in the distance between the inner edges of the two transducers at the next measurement point compared with the previous one. Sampling interval. Select a value from 0.054 microsecond. Sampling length. The number of recorded waveform points, which can be selected from 768,4096 points. Reference. The host can refer to two regulations, namely GB, D50784 Technical Standard for In Situ Inspection of Concrete Structure, and 621 Technical Specification for Inspection of Concrete Defects by Ultrasonic Method. Zero sound time refers to the delay caused by the signal transmission of the detector itself, and its value should be deducted. Specific steps. Click zero setting on the right side to enter the sound time measurement interface, following the prompts on the interface. Apply the couplant on the radiation surface of two ultrasonic transducers, and stick them together. Remove any air gaps, and then click Sample to collect the first sound time value. When the image stabilizes, click Stop to display the sound time value obtained from the first collection. Click Sample again, wait for the image to stabilize, and then click Stop to display the second sound time value. Repeat this process for the third collection. After 3 times of sampling, click Back, and the parameter interface will automatically display the zero sound time value. During the collection process, you can also click Retest to recollect the sound time values. If the process of collecting zero sound time is incomplete, and you need to exit the collection, a prompt box will appear, asking if you want to abandon the test. Click No to proceed with the measurement. Click Yes to cancel the current sampling, and return to the previous interface. If necessary, the tester can manually enter the zero sound time value, which ranges from 0 microsecond to 20 microsecond. Sound velocity refers to the value obtained by the non-cross-seam test. Each component must be conducted to a sound velocity test, non-cross-seam test, before the cross-seam test. Click Test to enter the sound velocity test interface. The interface is similar to the sampling interface, but does not display sampling information. There are testing steps for sound velocity testing in the lower right corner. The detailed operation steps are as follows. First, press the non-cross-seam positioning stamp on the same side of the crack, and apply couplant to both transducers. Then, keep one transducer consistently touching the outer middle of the transducer positioning line, tangent to the line. Place the other transducer from near to far within the transducer distance measurement circle, and start the non-cross-seam sound velocity measurement. Click Sample on the host to start the test. The highlighted row in the data list area represents the currently tested data. During the test, apply pressure to the transducers to prevent slippage. When the image stabilizes, click Save to save the value from the first measurement, ensuring good coupling between the transducer and the testing surface without any foreign objects or air bubbles. After saving the sound velocity values for 5 measurements, click Sample to return to the previous interface. This interface will display the newly measured sound velocity value. After all the parameters are set, you can enter the crack sampling interface. Click OK to enter the crack sampling interface. This interface is mainly divided into component information area, manual adjustment area, waveform display area, data list area, and function options area. Component information area. The component information of the ultrasonic measurement is displayed in the component information area. When the manual waveform adjustment option is selected, this area provides an operation prompt. Manual adjustment area. It allows manual waveform shifting and adjustment of gain. Different adjustment functions can be switched depending on the testing state. During sampling, the upper options are to shift waveforms horizontally. The lower options are to adjust gain and threshold and shift waveforms vertically. When the sampling stops, the upper options are to switch to the sound time determination function and manually adjust the sound time available. Waveform display area. This area mainly displays the changes of the ultrasonic waves currently being collected, and there are 3 data related to the current waveform in the upper left corner of the waveform graph, which are Ts, Dg and Ad. Wherein Ts is the sound time value at the leftmost of the display area of the current waveform graph. Tg is the sound time difference between each dotted line in the direction of the horizontal axis in the waveform diagram, and it represents the magnification of the current waveform diagram. Data list area. It displays the currently measured ultrasonic data. Among these data, the distance measurement changes in turn according to the settings in the parameters. Sound time and waveform amplitude change with the waveform during sampling. The cull flag indicates significant deviations or distance measurements that do not meet the requirements of the procedure, and points with cull flags are not included in the calculations. Calculated depth refers to the depth of the crack calculated from one distance measurement, while the crack depth is obtained by synthesizing the calculated depths from multiple distance measurements. In other words, the crack depth is the final result. Function options area. In this area, click parameter to return to the parameter interface for settings. Once sampling is started and measurement points are saved, parameters in the parameter interface cannot be modified. Click Sample to start the sampling process. Click Save to save the current setting. Click New Crack to save the current crack, and create a new crack under the current component. Click Exit to save the current data, and return to the main interface. Note: it is necessary to test for distances, calculate the crack depth, and then click Exit to save the current test data. After familiarizing yourself with each area, please proceed to the formal crack depth sampling. First, use the cross-seam positioning stamp to arrange the measurement points. The stamps should be tightly joined at the crack location, but should not overlap. Avoid honeycomb and pockmarked surfaces, and if necessary, use a grindstone for polishing. During the formal sampling, place the transducers at the measurement points symmetrically arranged on both sides of the crack within the first distance measurement circle. Click Sample on the screen to start collecting the crack depth values. After the image stabilizes, click Save to save the crack depth from the first measurement. Move the transducers to the second distance measurement circle, wait for the image to stabilize, and save the second measurement value. Repeat this process for 5 measurements. When the distance measurements have been saved, and the instrument calculates the crack depth, the rightmost column in the data list area will display the crack depth, which is the final result of the crack test. At this point, you can click Exit to save the crack measured for the current component, and return to the main interface. After completing the crack depth test, you can view the data. On the main interface, click Manage Data to enter the Data Management interface, which includes 2 functions, namely Data View and Data Delete. Click Data View to enter the crack depth test data record list. There are 2 tables in this interface. The component information list is on the left, the crack information list is on the right. Click a crack to view the detailed original data of the crack depth test. Click Rows to view specific data for a crack, or scroll up and down to view the data. At the bottom, click to select the next crack and view its data. Click Data Delete in the Data Management interface, and a prompt box will pop up, asking if you choose to delete all component data on the current host. When using the instrument, you can customize the system settings according to your personal preferences. On the main interface, click Set System to access the options that can be modified, such as key sound, light brightness, close time, and time date. Language settings: select the appropriate language as required.